So hello everyone. First of all, thank you very much for being here. Today I will talk about implementing a zero-downtime migration strategy in software as a service project. And imagine you are a big player in e-commerce stage like Amazon, and you are forced to take a maintenance break. And last time they experienced downtime, they were losing $66,000 per minute. And we faced a similar problem in Sailor, an open source e-commerce platform. Obviously not at this scale because we are not yet as popular as Amazon, but still the problem is the same. And I will show you how we handled this situation and the obstacles that we faced along the way. So before we start, let me quickly introduce myself. And I came from Poland. I've been using Python in my work for over 6 years right now, and I'm working on Sailor platform for almost 5 years. And I'm happy to see how this project is changing from just an open source project to a proper product. And firstly, I would like to shortly tell you the story about Sailor. So Sailor started as a small open source project built on Django with views. Then in 2018, the big decision was made and GraphQL API was added. A year later, Django views were totally removed, making Sailor a headless app, which basically means that we started to offer just an API without the front-end side. Over time, Sailor grew up, we gained a community around, and the idea to build a product around Sailor came up. And this leads us to the creation of the full cloud platform that offers Sailor as a SaaS product. And as you can see, the story behind Sailor is constant growth. And when you are getting bigger, you are getting more clients, and you are facing bigger problems. And one of oh, sorry, I didn't see that. It's breaking. Oh. It's working right now. Okay, sorry. So one of clients' requirements is the ability to update versions without any downtime. So to sum up the background of the downtime problem is that SaaS clients of e-commerce platform that Sailor is don't want to stop their stores at any time, as of course it means losing money. So we need to ensure that the system is working all the time, even during the updates, and to minimize the migration time. So I think it's safe to say that sooner or later each SaaS application will face downtime problem. So let's move on to some examples. And I will start with showing you the problematic operations, and then we will move to the solutions. So for this talk, I created a simple Django project with GraphQL API and database on PostgreSQL. It's the same configuration as we have on Sailor. And let's assume that we are currently running version V1 of the system. We have multiple app clusters that are using the database. And we want to apply some changes on product type in the next version, V2. And here is the product model on our current version, V1. The product model, the model is just simple Python class that refers to a single database table, and the class fields refers to the table columns. And in simplification, it's basically what object relational mapping is. So let's assume that our product model have a name, description, and created fields. And on version V2, we want to add new Slack field that will be a human readable identifier of our product. And additionally, we want to rename field created to created at to be consistent with other parts of the project. So as we previously stated, we are currently on version V1 of the system. And let's assume that we released mentioned changes in the next version V2, and we want to upgrade to this version. So upgrading app instances is easy. We simply need to gradually replace old instances with the new one. The problem is with the database, because it's shared resource and we cannot just clone it and replace it. Instead, we need to modify it in place. So we will begin with migrating the database to version V2. And as a result, we'll be in the stage where the app clusters are on version v1, but the database is already on version v2. And once the migrations are completed, we can start the app workers of the next version v2, and then finally shut down the app workers of version v1. So the two stages that we should worry about are 2 and 3, where we have the upgraded database, but still running workers on the previous versions. In other words, we have the old code that is using the upgraded database. And we analyze these stages in the following examples. So let's move on to the problematic operations. So we'll start with adding a unique Slack field that will be human readable identifier of our product. Okay, so what you see on the right is Django migrations. And for those who don't know, migrations propagate object relational mapping changes into the database schema. Simple speaking, the database needs to know that something has changed in the models. And migrations allow to define operations that will be performed on the database, but also allow to call some Python function that will make updates on instances. And to add a unique field, we need to firstly add a new label field. So basically, we will create a new Slack column on the product table in the database. Then we need to update existing instances to set the proper Slack values. And we will call the Python function that will do that synchronously. And after the function is finished, we'll have our new Slack column filled in with the proper unique values. And at this point, we'll be ready to perform the last step, which is changing the Slack into unique. So to apply this change, we are just altering the Slack column on the product table. So let's assume that we release these changes in version v2. We upgrade database to this version, but we are currently on version v1 of the system. So when the API request for product creation is called for second or subsequent time, the integrity error is raised. And the error message is saying that the product with empty Slack value already exists. And this is because version v1 is not aware that a new unique Slack column was added, and it's trying to save the row with null value for the Slack. And below you can see the part of the product table that is showing described situation. So we have 2 instances with proper Slack values and 1 with empty value as a Slack. So adding the next row with an empty Slack is causing an error, as the values won't be unique anymore. So we'll discuss the solution later. And now let's move on to the second operation. That is renaming a field from created to created at to be consistent with other part of the project. And seems to be pretty simple operation. We just need to rename the column from created to created at. But it might be problematic as well. So as before, let's assume that we release mentioned change in version v2, and we update the database to this version, but we are currently on version v1 of the app. So as we can expect, when the API request for product creation is called, we received an error. And the error message indicates that column created does not exist on product table. And this is accurate because we renamed this column, and in the database there's only created at column at this moment. However, the version v1 is not aware that something has changed, and it's trying to save the value on the old created column. And we will get similar error when trying to retrieve the product from the database. And this time, the API is trying to fetch the data from the created column, which does not exist anymore. So now let's move on to the last operation that we'll discuss today. And let's suppose we have a large data set of products, perhaps 1 million or more. So updating all instances will take significant amount of time, no matter how hard we will try. So the problem is that the update is blocking the migration process, as we need to wait for the update to finish to continue with the database migration. It also logs the database tables and keeps the database in the unstable stage, which may result in slowing down the application or even make it unresponsive during the update. And as a result, it significantly extends the time of database migration. So these were some of the problematic operations in context of zero downtime approach. So let's sum up them. So firstly, adding the unique or non-nullable field, like adding a Slack field in our example. And in Sailor, we were facing this problem, for example, when adding expiration date to our order model. Then updating a big number of data. And I can say that in Sailor, we are facing this problem most often, as our clients have quite a big collections of products and orders. And any field normalization, like for example, recently adding undiscounted price, means that we need to calculate each value separately. Then renaming the field, renaming the created field in our example, but also renaming the table, removing the field or table, or moving the data from one field to another. And all of this operation will cause a similar error like renaming the field. And in Sailor, we face this problem, for example, when changing ID to a universal unique identifier. So the key element is to not removing any fields that previous ORM will use and minimize each migration time. Okay, now, as we know all the problems, I overview the solutions. So the biggest difficulty in changing the version is updating the database, because it's shared resource and we cannot just clone it and replace. To ensure zero downtime, we need to ensure that the updated database will work with the old and the new version of the system. And there are two possible options to achieve that. We can make old code compatible with the new database schema, or we can make the new database schema compatible with the old code. And fixing old code is hard and it requires to craft 2 releases, so we decided to choose the second path, as it's easier to achieve. And I will describe the solution that fit this statement. And one more important thing is that we are ensuring zero downtime only when switching one version at the time. So in our example, switching from version V1 to V2 will be possible without any downtime, but switching from version V1 to V3 won't be. Okay, so basically the solution is to ensure the transition state with the use of expand and concat pattern, and it can be split into 3 phases. Firstly, in the expand phase, we need to extend the database schema and adduce the code to work with the both database schemas, the old one, the new and the old one. And then in the transition phase, we need to migrate the old data to ensure that we have data only in the new proper format. And then finally, in the concat phase, after ensuring that the old structure is not used anywhere, we can clean up the code and delete unused fields. And as a result, we will get the expected stage. So let's start with the solution for our first problem, which involves adding a unique Slack field. So firstly, we need to, in the expand phase, we need to add a new nullable Slack field. And also, we need to ensure that any newly created instances will have the proper value set on our new column. Then in the transition phase, we need to fulfill existing instances with the proper Slack values. And to minimize the migration time, we will delegate this update to the asynchronous task that will do this in the background. So the task will start after the migration process. And I will tell you more about that later. For now, the most important thing is that the update is done asynchronously. And when the tasks are finished, the Slack column will be filled in with the proper values and will be ready to move to the last phase, that is a contract phase on our version V2. And here we will be ready to safely change the Slack field into unique on our target version. Okay, so the second operation was renaming the created field, and to ensure the compatibility, we have to perform the changes in three main steps that are adding a new field next to existing one. Then we need to copy the data from the old field to the new one, and then finally remove the old field. And on each of these steps, we need to ensure the transition state. And yeah, so let's go into details. Okay, so as before, in the expand phase, we need to add new label, new created add column. And we also need to adduce the API. So when any new product is created, it will have proper value set for both columns, the old one and the new one. Then in the transition phase, this time we need to copy the data from the old column to the new one. And as before, we delegate it to the asynchronous task that will do that in the background. And after the task is finished, we can move to the last phase, that is contract phase on our target version V2. So on this version, we need to remove the old field from the ORM and from the code, as we don't want to use it anymore. But we cannot remove it from the database because it's still used by the previous version V1. So instead, we need to ensure that the old created column is nullable or have a default value. So to perform those actions, we need to separate the database and ORM changes. So on the migration on the right, we are removing the old created field from ORM, but not from the code, not from the database, sorry. Instead, we are altering the old created column to make it nullable on the database. And we are also ready to change our new field into our new field created add into non-nullable. So, okay, so after contract phase in version V2, we'll be in the state when the old created field is not used anywhere in the code, but it's still in the database. So we will need one more extra step to safely get rid of that column. So in the next version, after ensuring that only new field is in use, we are able to safely remove the old created column from the database and to achieve the target state. And as you can see, there is quite lots of steps to just rename the field. Now let's take care of the update of large data sets. So the update should take place in the transition mode, so we can ensure that instances have proper values, and we can safely apply the changes on the target version. And to minimize the migration time, data should be updated asynchronously after the migration process. And here is the example of the migration that calls a task that copied the data from old created to new created add column. And the task is delayed in post-migrate signal, which means it will be called after all migrations are completed to not bother the migration process at any way. So the data will be copied in the background after all database migrations. And now take a look at the task code. I have some tips for you. So firstly, updates should be done in batches. And secondly, ensure that only instances that haven't been updated yet are taken for update. And the instances should be sorted by some unique field like primary key. And in this example, we are taking the products that have empty created add column. And after the batch update, the task should queue itself to not block the asynchronized task queue for too long. And also what's important, the update of instances should be done in a transaction with locked rows to avoid potential deadlocks that might happen when multiple asynchronized task workers are in use. So right now, we know the problematic operations. We know how to write migrations to not crash the system. So the last missing piece is how to proceed with version update. So firstly, we must release the applied changes on expand and transition phases as a patch or minor release. And I will use minor release v11 for simplification. So in our example, on version v11, we will have two new label fields, Slack and created add. And next, we need to upgrade firstly to this minor version that will be our transition state, and then to the target version. So firstly, we need to switch from version v1 to v11, and then from v11 to v2. And upgrade through this version v11 is crucial. So in both cases, the process will look the same, so I will describe it on example from switching from version v1 to v11. So we'll start from the configuration where we have one app instance that is using the database, and we have two asynchronized task workers, for example, salary workers. So the first step is stopping the asynchronized task workers to make sure that they don't process any task during the database migration. And then we need to run the database migration to update database to version v11. And after the migration is finished, we can start the app workers of version v11. So let's notice that at this point, we have app instances of two different versions that are using the same database. But we ensure the compatibility, so when any new product is created on version v1, it will have the null value set for both new columns. And when the product will be created on version v11, it will have the proper value set for both Slack and created add columns, as we had used the API to do that. So then in the next step, we should stop the app workers of the previous version, and finally, at the end, start the salary workers to run the task delegated in the database migrations. So in our examples, tasks in the background will fill in empty values for our new columns. So I described you the zero downtime upgrade. Now let me digress a little what zero in zero downtime really means. So during the update, there is no moment when all app instances are stopped. Instead, the data is upgraded in place while the app instances are still in use. So this may result in minimal downtime, but it's so brief that it's essentially zero and not visible to the user. Okay, so moving back. After upgrade to v11, any new instances will have the proper value set. Old instances will have the null for the start and will be updated by the asynchronized task in the background. So when the tasks are finished, the product table will be filled in with the proper values and will be ready to upgrade to our target version v2. And to do that, we need to perform the same steps as for switching from version v1 to v11. So if you want your upgrade to go smoothly without any maintenance break, remember that the most important thing is to not remove any fields that previous ORM will use. So basically ensure the transition state. And that's it. Thank you. I just wanted to add that here is the link to the seller site and also the example project that contains all examples that I used today. So thanks.
Thanks a lot, Ida. We have a lot of questions. If you have some more, please keep them coming in Slido on Room Spaghetti. The first one is, does using GraphQL make the zero downtime migration easier or difficult?
I think it doesn't matter.
All right, next one. Did you ever consider using MongoDB? The questionnaire says this would force the program to be developed in a way that is compatible with any schema version, reducing migration trouble.
We didn't consider it, but I think it's not matter what the database is used here.
Okay. And do you think Django could or should add extra tools to make zero downtime migrations easier or more manageable? And in the same regard, do you have any automations in place to make the migrations easier or more manageable?
I saw recently that there is some package for PostgreSQL that allow to perform this migration, like you are just describing the, I think, JSON, and you are telling what should be changed. So there are some steps to make it easier.
All right. The next question is, what do you think about backwards data migration? Is that something we should take into consideration?
Once again, sorry?
What do you think about backwards data migration? I think it's in terms of rollback, maybe, rolling back the migration?
Yeah, so this solution, like, you need to just make a backup, I guess, before starting this.
Okay. It's always a good practice, I guess, to have a backup anyways. The next question is, what if the expand phase, for example, when you add a column during the expand phase, already takes an unacceptable amount of time, if it's very slow? Does that have any impact on the migration?
The expand phase? No, usually not. Like, it's usually it means that you need to write to one more column. So I think it's not a big deal.
All right. Then the next question is, if Sailor switched to API only, why didn't it change the backend from Django to Fast API, for example? Are you planning on migrating that in the future?
Right now, no, because we are on still growing phase and there is no time for that. But I think maybe in the future.
The next question is, after dropping the old column to reclaim the used disk space, you will at some point need to do a full disk vacuum. How do you handle that without locking the table?
Can
okay,
I
yes, sure. This
one?
Yes.
Okay. Oh, it's a tricky one, to be honest. So it's hard to me to answer this one, sorry.
No problem. The next one is, for the column rename problem, there's a moment between the value duplication and the software update. In this period, the new record can be created with the created column. Oh, I should have read this before. I'm not sure. Maybe you care to clarify, whoever asked the question? Was it you? Yeah, then, I mean, maybe you can.
Okay.
Yeah. When you duplicate the value of the created column, and you update the software in order to read and use the new one, maybe there is a period of time that the old software create maybe new records with the created column values. So after the software migration, do you copy this old value to the new column?
Like, there's maybe, I will move back a little. So here, in this moment, yes, when you are version v1, it will create like new instance with value set only on old column. The new will be empty. So right now, nothing's changed. Then when I'm stopping the API instance of v1, so in the database there will be values, like the column will look like that at this moment, and the celery task will fill in those values. So right now there will be no moment that I will get new rows with empty slack and created add columns. It's the the state that I will be updated in the background. And right now, when any new product will be created, the values will be properly set on both columns.
Great. There's another question about linting. Do you have any linters that run on the migration files to ensure that you're actually following the process that you presented?
I think that the easier way is just to run some SQL statement to check if how many empty columns, for example, do you have? So it will show.
And do you have a recommendation to monitor any of the background tasks you're running? So basically to know when you're done with the migration?
No, because I'm not working on this part of the project. I'm just responsible for creating this, for ensuring that the code is prepared for that. But I think you just need to check the salary queue or another asynchronous task queue to ensure that that is finished.
Okay, there's some other mention here in the comments that the SQL migrate command can also help to spot cryptic behaviors in the fields default, creating a migration operation that backfills at the rows. I don't know what that comment is like. Is that a question actually behind that? Maybe the question taker would like to clarify that. Okay, then feel free. No matter what. Then let's continue with the next one. How about renaming tables when you do migrations? Is it also possible in zero downtime?
Yes, yes.
Okay. Can you maybe explain how it works a bit?
I will have to think about that. I think it's not like short because we didn't do that, to be honest. But we can stay after and maybe discuss it because it's hard for now to.
Sure. This is a longer slot, so we have some time after this talk before the next talk start in the other room anyways. So then we have two more questions, I think. One of them is, do you test the migration on some test database before actually running it on production, or do you just fire it at production right away?
Again, I'm not responsible for doing that, but when I'm implementing the changes, I'm always checking it on the local machine. But yes, when it's on production, I know that the team that was responsible for that was doing the test, right?
All right, then thanks, Iga.
Thank you.